All right, we're going to continue our discussion on displaying relationships, and today we're going to talk about correlation. This is 3.1b lesson, and really we're going to interpret what R is. All right, R is the regression coefficient, our correlation coefficient, sometimes it's called, and it basically tells us the direction and form and strength of our linear relationship. First off, direction. If we have an R value that is positive, okay, then we know that the slope is going up. Okay, it's going up. Negative, we know that the slope is going down. All right. The form that we're always looking at is it's always going to be a correlation to linear. All right. Is the display linear or not, or how strong is it going to be linear? Not saying it will be linear. That's just something on the strength. Okay, so that's kind of confusing. But how strong is it to this linear relationship? Well, if it's negative, -1 to -1.5 to 0, all right, that is going to be a negative strong relationship because -1 is the highest you can go. Moderate is around -0.5, -1.5. Weak is right around 0. 0.5 is a moderately strong, and 1 is very strong. Using Lee's, okay, when we're talking about these, like moderately, somewhat strong, and so on and so forth, it's kind of hedge your bets when we're talking about the strength of a correlation. Now, R does not have units. So when we're talking about the R value, this correlation coefficient doesn't have units. Switching to X and Y does not change the R value, all right? It still has the same correlation. It is not resistant to outliers in pattern strength, okay? That means that when you have outliers, it will change the R value. Okay, so it is non-resistant. Resistant, remember that it won't change it. So it is non-resistant. So outliers in the pattern will strengthen it. Outliers outside the pattern will weaken it. Okay, so if you see a thing, if you see an outlier, and when we refer to an outlier, all right, an outlier can be up here. If you have a bunch of different dots, and one weight right here, this might strengthen it. However, if you have one that's more of an outlier over here, that might weaken it. So farther out it is, the more it will strengthen, all right, your correlation. The closer it is outside of the pattern, the more it will weaken the correlation. Hopefully that makes sense when you see that. Now, once again, correlation does not mean causation, all right? Just because there's a correlation does not mean that it is caused. There can be some other variables involved, all right, in our relationship. So without further ado, let's check our understanding of these notes. All right, so if you want to pause this, you can pause it and write this down. But let's go to it and check your understanding. So here we talk about the love of chocolate. But does it make you smarter? A scatter plot listed below has recently appeared in New England Journal of Medicine. The explanatory variable is the chocolate consumption. So explanatory, all right, is going to lead to our outcome. All right, so our predicted value. So does that lead to a response variable of Nobel Prize winners? So people are smarter per 10 million people. And so what we see is that we have all these different dots around here, okay, China and so on and so forth, and we see the number of Nobel Prize winners out of 10 million people, okay, a lot of people from Switzerland and whatnot. But you see the chocolate consumption right here. So if we saw this R value, it's an R value of 0.79. So what does it mean? All right. Well, it means the relationship between chocolate consumption, consumption, and all right, Nobel prizes is a positive, right? Because that's positive. Moderately strong. So moderately strong because it's right around 0.5, so it's moderately strong. Strong linear relationship. And that's what we see right there. Okay, so positively, moderately strong linear relationship. So positive, because it's positive, mildly strong, right around 0.5 linear relationship. Now, if people in the United States started to eat more chocolate, can we expect more Nobel Prize winners awards to the residents of the United States? The answer would be no, no. All right. What we know is that association does not lead to causation because there may be other factors that would increase the number of Nobel winners. All right, or Nobel prizes. Okay, in the country. Right, and that makes sense, because it could be, playing favorites for European countries or so on and so forth. There are more scientists and more research is done in those areas, and so on and so forth. So a lot of other things besides just chocolate consumption, but it is an interesting fact. Now, what effect does Switzerland have on the correlation? Well, when we see this right here, Switzerland is over here. Now, is that outside the pattern? Does it weaken it, or is it follow the pattern? Is it more of an outlier on the outside that would strengthen it? Well, it appears that this would probably strengthen it because it does kind of follow with this. As chocolate consumption increases, so does Switzerland, who was way at top. So it probably, this outlier strengthens the correlation. As it follows the pattern. Okay, pattern which is a positive, mildly strong linear pattern. All right, so as chocolate consumption increases, so does the Nobel Prize winners in those particular countries. All right, so that's how we do it. And that's our trick understanding of how to use correlation to describe data, also, and how we can reaffirm that no association relationships do not lead to causation because there are other variables in there. And then also, how do we identify outliers and which ones strengthen the correlation and which ones may weaken it. Hope this helps you out, and good luck and God bless in the rest of your problems.